All right, how good. Final section in the textbook for us. So this is about confidence intervals for proportions, testing claims about them. So a nutrition expert found that 43% of Victorian children ate insufficient fruit each day. And sorry, I should really explain. This is just an example question. I'm just jumping straight into an example question for us, just to do this to talk about it. So to check whether this figure was the same for Western Australia, a university research group sampled 625 children and found that 308 ate insufficient fruit each day. So construct you'll notice the text says 95. I changed this to 90 so we can practice doing that. Confidence interval for the proportion of West Australian children eating insufficient fruit. So in this space straight off the bat, we are given a proportion. So we should know here that our proportion is going to equal 308 over 625, okay, and then we've got our number of trials. Let's just put that in because n equals 625 is good there, okay, and then we've then got our proportion formula. So I'm going to go back up and grab this bad boy here, no, a bit further up. This one here, just so we can practice. So we've got this thing here. Now, I'm going to be a bit lazy and also there's not a heap of room here. So let's just go in here and we're going to erase proportion because we know that already. So 308 divided by 625, 308 divided by 625 gives us 49.28. So going to zoom in a little bit here. So we got, this is going to equal, let's move that. We don't really, we've got that is 0.493. I'm going to round that. Okay. So actually, no, let's not round it because if we've got it as a recurring decimal, we've got a better answer and then we can round at the end. So we got 0.4928 and then here we've got a 0.4928. Oh, running out of room. Let's just erase that plus 4928 plus. Now our z-score, should we finish no, let's do our z-score next. So let's go into our calculator. We go stats mode, distribution, normal, inverse, and we're making sure our sigma. So we got data is variable, we got sigma for standard deviation is 1, mean is 0, area is going to be 0.9, and tail is central. We calc that and we get our value of, let's erase these. These now equal 1.64. 0.64. Okay, now here I'm going to have to erase these numbers in here and this number under the bottom. So n was 625. That's how many trials we had. And then we've got 0.4928, and that is going to be times by, if I go back into my calculator, 1 minus 0.4928 gives me 0.5072. All right, so that's good. I wish I had left myself more room. Let's copy that and we'll just paste that over here for a minute. We'll erase all this and this. Okay, I'm just going to move that in there. So I've set this up for a 90% confidence interval instead. So we're only 90% sure. We're not as sure here. And the value we get is going to be given by, hang on a sec. We're going to be given here. So when I put that all in my calculator, I'm going to be looking at one proportion. One proportion, let me execute that. Okay, so I've got here 0.459. Okay, now that would round up as well because I've got the double there. So that's actually 460. Oh, hang on, I've changed my colour. 0.460 less than equal to proportion less than equal to 0.526. Okay, sorry, a little bit of extra work there just because we did that. I just wanted you guys to see it to practice so we know we've done it. So we've got our confidence interval here. We know our proportion is between these values. And then we've got how does the proportion of children not eating fruit in Western Australia compare with that of children in Victoria? So in this bit here, the proportion in WA here that we calculated, which we're 90% confident about, means the kids in WA, we're 90% sure they eat more fruit. Their proportion is in this value. So in this answer, we would say the proportion in Victoria of 43% does not exist, like it's not within the interval. So the proportion of children that eat insufficient fruit in Victoria is not within the 90% confidence interval for Western Australia children. Therefore, we can assume, therefore, there is evidence that the proportion is different in the two states. Now, we're just got to be really careful here because you got to remember that this confidence interval here, the WA proportion could still lie at 43%. It's just we're 90% sure it lies between these two values. So when you're testing, remember, it's never definitive. If it's within the value, it supports the claim. If it's outside the value, there is evidence to suggest that the proportions are different. All right, thanks, guys.